This content is produced by Pass the CSLB, an independent audio-first study companion for busy California B General candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. Concrete cover is not measured to the center of a reinforcing bar. It is the shortest distance from the finished concrete surface to the outermost surface of the nearest reinforcing steel. That one definition controls almost every field decision in this lesson. If a tie, hoop, or stirrup sits outside the main bars, that outside piece is the steel that controls the measurement. I want you to think of cover as protective distance. The harsher the exposure, the more distance the steel generally needs from the outside environment. That distance gives moisture, chlorides, and carbon dioxide a longer path through the concrete before they can reach the steel. It also places more insulating concrete between the steel and heat during a fire. The cover is not decorative, extra concrete. It is part of how the reinforcement remains protected while the member performs its structural job. Suppose a crew is forming an interior concrete column. The approved detail calls for 1 1/2 inches of cover. The crew measures from the form to the large vertical bars and gets exactly 1 1/2 inches. The problem is that smaller horizontal ties wrap around the outside of those bars. The ties are closer to the form, so the actual cover is less than the required distance. I would stop that condition before the pour. The measurement must run from the form face, which becomes the concrete face, to the outer edge of the closest tie. It does not run to the center line of the main bar, and it does not ignore the steel that happens to be smaller. Concrete does not know which bar the crew considers primary. The nearest steel is the nearest steel. This is why a quick glance at the cage is not enough. I want the tape placed at the actual controlling locations. On a footing, that may mean the bottom bars, the side bars, a corner tie, or a bar that is shifted near an irregular trench wall. On a wall or column, it may mean the outside face of a tie or hoop. The approved plans establish the intended placement. Field supervision verifies that the built work matches that placement before concrete hides it. The practical timing matters. Once the ready-mix trucks are on site and the pump is moving, nobody wants to untie and shift a cage. The useful inspection happens before that pressure arrives. I would verify the forms or earth faces, the controlling steel surface, the support system, and the stability of the cage while correction is still straightforward. The first exposure category is concrete cast directly against earth and permanently exposed to it. Picture a footing poured into an excavated trench with no side form, between the wet concrete and the dirt. For that condition, the minimum cover is 3 inches, regardless of reinforcing bar size. The second category sounds similar, but is different. Concrete exposed to earth or weather may first be placed inside forms. The forms create the concrete face. Then the forms are removed and the member remains outdoors or is later backfilled. In that formed and exposed condition, number 6 through number 18 bars require 2 inches of cover. Number 5 bars and smaller require 1 1/2 inches. The third category is protected interior concrete that is not exposed to weather and is not in contact with the ground. Interior slabs, walls, and joists using number 11 bars and smaller require 3/4 of an inch of cover. Interior beams and columns require 1 1/2 inches for primary reinforcement. Looking at the reference table, I want you to notice that the rule is not simply exterior versus interior. I first identify whether the concrete is cast directly against earth, formed and later exposed, or protected from weather and ground contact. Part 3, then I look at bar size or member type where the rule requires it. The most important wording distinction is cast against earth versus exposed to earth. Cast against earth means the wet concrete is placed directly against the raw excavation. Exposed to earth means the concrete face can be formed first and later placed in contact with soil. Those phrases are close enough to sound interchangeable, but the cover values are not interchangeable. For exterior non-pre-stressed concrete, a useful memory countdown is 3, 2, 1, 1/2. 3 inches is the direct earth condition. 2 inches is the formed exterior condition with number 6 through number 18 bars. 1 1/2 inches is the formed exterior condition with number 5 bars and smaller. I keep the protected interior values separate because interior slabs, walls, and joists can drop to 3/4 of an inch, while interior beams and columns remain at 1 1/2 inches for primary reinforcement. That memory aid is only a starting point. I would never use it to override approved structural plans, project specifications, manufacturer requirements, or a more restrictive applicable requirement. My role in this lesson is field execution and verification, not structural design. Cover tolerances are another place where a correct number can be used incorrectly. For members 12 inches or less in thickness, the maximum general negative tolerance for concrete cover is 3/8 of an inch. Negative tolerance means the steel is closer to the concrete surface than the specified position. But that 3/8 allowance has a backstop. The reduction cannot exceed 1/3 of the specified cover. Both limits apply, and the smaller permitted reduction controls. Take the protected interior slab example with 3/4 of an inch of specified cover. 1/3 of 3/4 is 1/4. The general negative tolerance is 3/8, but 1/4 is smaller. That means the permitted reduction is limited to 1/4 of an inch, leaving at least 1/2 inch of cover in that tolerance example. This is exactly the kind of arithmetic that causes trouble when somebody remembers only the larger general tolerance. 3/8 does not automatically apply in full to every cover dimension. The 1/3 rule prevents the tolerance from consuming too much of a small specified cover. I also want to separate tolerance from target. The target is the specified cover. A tolerance recognizes limited field variation. It is not an instruction to install the cage intentionally at the low edge. If the cage starts low and then shifts during placement, the finished cover can fall outside the allowed range. Good supervision aims for the specified position and uses supports that can hold it there. That brings me to the support system under slab reinforcement. When a slab is placed over a vapor retarder, maintaining steel elevation and protecting the membrane have to happen at the same time. Thin, pointed chair legs can concentrate load and puncture the plastic as workers cross the steel, the pump hose moves, and wet concrete is placed. The source-backed field approach is to support reinforcement on load-bearing pads, or precast concrete blocks commonly called dobies, or to use chairs equipped with broad sand plates suited to the membrane condition. The broad-bearing surface spreads the load instead of focusing it through a sharp point. I treat the vapor retarder and the rebar support as one coordination problem. A membrane can be installed correctly and then damaged by the next trade. Reinforcement can be set at the correct elevation and still create a moisture defect if its supports pierce the retarder. The successful condition preserves both systems. Imagine a hypothetical slab where standard pointed wire chairs are set directly on a vapor retarder. After the reinforcing grid is loaded by foot traffic, small punctures appear throughout the membrane. The steel may still look neatly elevated, but the moisture barrier is no longer in the condition that was specified. I would stop and correct the membrane and support method in accordance with the project documents and product requirements before authorizing the pour. A pre-pour inspection should answer a few connected field questions without turning the contractor into the engineer. I verify the required cover against the approved plans and applicable requirements. I measure to the outermost steel. I check that the cage is supported and held in position. I look for locations where a trench wall, form, tie, or shifted bar changes the actual distance. Over a vapor retarder, I verify that the support system is not puncturing the membrane. I also look at sequencing. Soil can slough from an excavation. A support can tip. A cage can be pushed by traffic or placement activity. A correction made early may take minutes. The same correction after concrete placement can become demolition, engineering review, delay, and added costs. That consequence chain is why the pre-pour walk matters. The research also identifies a narrow special inspection point. Continuous footings supporting light frame construction, fully on earth with design strength of 2,500 psi or less, are exempt from continuous special inspection. That exemption should not be stretched into a claim that no required inspection or contractor verification applies. It addresses continuous special inspection for that stated condition. It does not erase the need to follow the approved documents and the authority having jurisdiction. I am deliberately keeping the professional boundary clear. A General B contractor coordinates, supervises, reads the approved details, catches placement errors, and gets the work ready for inspection. I am not teaching you to select bar size, bar grade, structural spacing, or reinforcement quantity from load calculations. Those are design decisions that must come from the appropriate approved design professional and project documents. Reinforcing steel also creates an immediate job site hazard before it ever becomes part of the concrete. California workplace safety rules require employees to be protected from impalement on exposed protruding reinforcing steel that extends up to 6 feet above the grade or work surface. A small plastic cap that prevents scratches is not automatically an impalement protection device. For manufactured protective covers, the minimum bearing surface is 4 inches by 4 inches when square, or 4 1/2 inches in diameter when round. Job-built wood protective covers have a separate performance requirement, or they must withstand the impact of a 250-pound weight dropped from 10 feet without failure. The safety table separates 3 ideas that are often mixed together: the height condition, the minimum manufactured cover surface, and the job-built impact test. I want you to remember that true impalement protection is about both area and strength. The physical effect is straightforward. An exposed bar presents a narrow point. A broad, load-bearing cover spreads impact over a much larger surface. The impact test addresses whether the cover itself can survive the load instead of breaking apart and exposing the bar underneath. Consider a hypothetical site where every vertical dowel has a bright plastic mushroom cap. The site may look organized, but appearance does not establish impalement protection. I would verify that the product is actually manufactured and rated for that use, or that the job-built cover satisfies the applicable construction and impact requirements. Color and shape are not substitutes for performance. I want to leave you with one connected field method. First, identify the exposure condition. Is the concrete cast directly against earth, formed and later exposed, or protected from weather and ground contact? Second, identify the controlling bar size or member type. Third, measure from the future concrete face to the outermost steel, including ties, hoops, and stirrups. Fourth, confirm that the support method holds the cage without damaging another system such as the vapor retarder. Fifth, protect protruding steel with equipment that actually meets the impalement requirement. Then complete that verification before the pour makes the work inaccessible. The central memory is simple. Cover is protective distance and exposure controls the distance. Direct raw earth gets the largest cover taught here. Formed exterior concrete uses the bar size split. Protected interior slabs, walls, and joists use the smallest value taught here. Every one of those dimensions is measured to the steel closest to the surface, not to the bar that seems most important. This is a testable concept based on the CSLB study guide because it combines concrete knowledge with defect recognition, inspection readiness, trade coordination, and safety. The useful contractor skill is not reciting a number in isolation. It is choosing the correct exposure category, measuring from the correct point, and catching the condition while it can still be fixed. I made an audio practice quiz specifically for this episode's concrete cover material. It is audio-based. The questions are read aloud and you answer by tapping, so it works well for people studying on the go, between jobs, or during a busy day. If you are driving, listen only and wait until you are safely parked before tapping an answer. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about the cover dimensions, the tolerance example, vapor retarder supports, or rebar impalement protection. I read those questions because they show me exactly where the material is still unclear. Subscribe so I can help you stay on track through every episode until you get your license. I know this process takes discipline, and I want each lesson to make the next study session feel more manageable.